Okay, this is Algebra 2, Lesson 1.6, Solving Linear Inequalities, beginning on page 41 in the textbook. Simple and compound inequalities is what we're looking at today. You have a handful of definitions to start. A linear inequality in one variable is just like a variable equation, except it has an inequality symbol. So x is greater than or equal to 3, or 2y plus 7 is less than 4. So if you're talking about one variable, you're just talking about x or y or any other variable, not the inequality where it's both of them, where when we get to it eventually, when you're in Algebra 1, you're seeing something where you graphed a line that looked like this and then you had to shade one side. Not That's a two variable. That's not what we're talking about. The solution of inequality in one variable is something that makes it true. So if it was x is greater than or equal to 3, that means all of the numbers at 3, when you count that one and everything to the right of it, that makes everything true. Anything on the right-hand side counting 3 would make that one true. The graph of an inequality is all points on a number line. So the same example, at 3, if it was greater than or equal to, this is the graph itself, the picture. This is the graph itself, this part, the part that I have written in green up there, the whole thing. That's the picture that represents it, is the graph. A compound inequality is joined by and or. Now, or inequalities will be like x is greater than 3 or x is less than -7. But and inequalities, more often than not, will be combined. That'll look like this. If you said x is greater than 3 and x is, x is greater than 3 and x is less than 2. X is less than 7, for example. Greater than 3 and less than 7. More often than not, the x will be written in the middle, and it'll say less than 7, and it'll say greater than 3. It'll be written this way instead. And so that'll be all the numbers that are between 3 and 7 when you graph it. It'll be everything in between those. So that's compounds or and or inequalities. Okay, when you're adding, subtracting, dividing, and multiplying inequalities, they act just like equations with two distinct examples. These are the two right here. Anytime you multiply or divide by negative values, you have to reverse the symbol. Otherwise, everything is exactly like an equation. That is the only distinct difference. If you multiply or divide, and only when it's by a negative value. Here's example number 1. It says solving inequality with a variable on one side. 5x plus 7 is greater than -3. You still do everything just like an equation. Normally you work please excuse my dear Aunt Sally. But when you're undoing, you work backwards. You work sad mep. You work Sally and dear my excuse please. You work it that way. So you look for any subtraction and addition first. It says plus 7, so you undo plus 7 by subtracting it on both sides. -3 minus 7 gives you -10. Then you go to the next step, division and multiplication. Get rid of 5 times something by dividing by 5 on both sides. And you divided by a number, but you divided by a positive 5. The fact that it said -10 being divided by positive 5 doesn't matter. It's what you divide by 5 here. It's positive. You divide this side by 5. Notice we do not reverse the symbol in this case to get x is greater than -2. When you graph x is greater than 2, you graph it with an open bubble, and you say everything to the right. An alternative to this, an open bubble means don't count 2. An alternative to that would be a parentheses at that spot saying don't count 2. Remember, if you wanted to count the number itself, you'd color in the bubble, or you'd make a bracket. Bracket means count that number as well. Okay, take 30 seconds to do this one. Gotta have to do it in the margin today. There's not a whole lot of extra space on the sheet. Okay, let's take a look at it. It says 11y minus 9 is greater than 13. Same steps. You want to get rid of minus 9 first because you undo addition and subtraction first by adding it. If you do it there, do it here. It leaves you with 11y. We didn't do anything to reverse the symbol. 13 plus 9 is going to be 22. So then get rid of 11 times something by dividing by 11. If you do it there, do it here. Y 22 divided by 11 is 2. We divided, but we did not divide by a negative number. Therefore, it stays just like that, greater than 2. You got that one right. Give yourself a pat on the back. Let's do something that's a little tougher. Solving an inequality with a variable on both sides. Now it's just like the equations. You want to move the smaller x over to the larger one. Again, just like the one Zoe did earlier, if you move the bigger one to the smaller one side, it's not wrong. It's just going to look a little different. Okay? So move the smaller one over. 2x is smaller than 3x. Okay? Now, with equations, we always say move the smaller variable over. But notice with this one that instead of moving the smaller 2x, it says move the smaller, it moves the larger 3x over. Okay? The reason you do that, and it's again, it's not wrong to do it the other way. It's easier for most people with inequalities if you move the variable to the left every time because it's easier when you see it to graph it. That's why they're bringing that larger 3x over. So it's positive 3x. If you subtract 3x from that side and you do it from 2x, you'll get negative x or negative 1x minus 2 is less than or equal to the 3x cancels out 1. So that's the reason. Again, it wouldn't be wrong to do it the other way. And if you fill this one out on your own, it might just read something a little bit different. It's just easier to see it and graph it if the variable's at in the beginning. Okay, so if you bring your x's to the left in this case, bring your constant number negative 2 to the right. So add 2 to both sides. That's how you cancel out minus 2. 1 plus 2 is going to be 3. But this is not the answer. This now says negative x is less than or equal to 3 or negative 1 times x if you need to show that in there. So in order to cancel out that negative 1 times something, you divide by negative 1. If you do that to the left, do it to the right. You know 3 divided by negative 1 is going to be negative 3. But since we divided by a negative number, you have to reverse the symbol. And less than or equal to is going to become greater than or equal to negative 3. So the solutions are all real numbers greater than or equal to negative 3. Okay, take about 40 seconds to do this one real quick. Again, bring your variables, even though 10's bigger than 7, bring it to the left. It'll be easier for you. Okay, we went a little bit more than 40 seconds, but let's take a look at it. Again, bring your x's to the same side. You want to either bring 10x over or 7x over. Usually you'd bring the smaller 7 over to the 10 side, but since it's an inequality, let's move our 10 over to the left. It's positive, so subtract 10x. If you subtract it on the right, subtract 10x on the left. 7x minus 10x is going to be negative 3x. You still have plus 9, you still have greater than or equal to, and you still have negative 12. Since our x's are now on the left, let's move everything else to the right, everything else being plus 9. You know how to cancel out plus 9 by subtracting it. If you subtract 9 on the left, subtract 9 on the right. Negative 12 minus 9 is going to be negative 21. You combine them. Again, we didn't do anything to reverse that sign, so you leave it there. You have negative 3x is greater than or equal to negative 21. Then cancel out negative 3 times something by dividing by negative 3. If you divide the left, do the same thing to the right. A negative divided by a negative is going to be a positive 7. You'll have x, but now we divided by a negative number. So our greater than or equal to is going to reverse and become less than or equal to. Okay, Using a simple inequality, it says a basketball player's average point total, A, in the last 5 games is X plus 123 divided by 5, where X is her score in the 5th game. Describe the scores that will give her an average of at least 30 points. So at least, there's one of those key phrases. That means 30 or more. So here we go. At least means greater than or equal to. So the average has to be at least 30 points per game. X plus 123 over 5, we had that earlier, now is greater than or equal to 30. So you work your order of operations backwards. Now, normally you would get rid of plus 123, but this acts as if it has parentheses around it. So you have to cancel out the division of 5 first by multiplying both sides by 5. When you multiply the left by 5, it cancels that out. When you multiply the right side by 5, 30 times 5 is 150. Now you just undo plus 123 by subtracting it on both sides, and 150 minus 123 is 27. So notice we didn't do anything to reverse the symbol. Now we have something that says X is greater than or equal to 27, which means that basketball player has to score 27 points or more in order to have a 30-point average. Okay, the 2 checkpoint problems, they solve negative 2x plus 5 is greater than negative 1. Undo your addition first by subtracting 5 on both sides. That leaves you with negative 2x is greater than negative 1 minus 5 is negative 6. Undo multiplication by dividing by 2 on both sides. Negative divided by negative is a positive. Anytime you divide by a negative number, you reverse the symbol. Greater than becomes less than. X is less than 3. Same thing with the other one, but now let's bring our x's over to the left-hand side instead of bringing the smaller to the larger. Minus 2x cancels out plus 2x. Minus 2x here. Negative 6 minus 2 is negative 8x. We still have 9 in front of it. We still have less than or equal to, and we still have 9 after it. You got x's on the left-hand side. Let's move the other part to the right. The other part in this case is plus 9 or positive 9. Undo that by subtracting 9. If you do it there, subtract 9 on the other side. 9 minus 9 is going to be 0. Didn't do anything to reverse the symbol. We have negative 8x is less than or equal to 0. Undo negative 8 times something by dividing by negative 8. You divide the left, do the same to the right. 0 divided by anything is still going to be 0, but there's a key here. We divided by a negative value. Therefore, we have to reverse that symbol. Less than or equal to becomes greater than or equal to, which means that x has to be greater than or equal to the number 0, which means x has to be a 0 or a positive number. A plant's height, h, in inches can be modeled by h equals 4.7 x plus 1, where x is the age of the plant in years. Describe possible ages of a plant that is over 4 feet tall. Over 4 feet tall, you have to first decide what that means. So describe possible ages. 4.7x plus 1 is over 4 feet tall, which means it is greater than 4 feet tall. Greater than 4 feet tall. Notice I reordered it. I put this part first, and I put the height second. So now just solve the inequality. Undo plus 1 by subtracting it. Do same thing here. 4 minus 1 is 3. 4.7 times x is greater than 3. Undo 4.7 times x by dividing by 4.7. Do the same thing here. 4.7. X is greater than 0.638. So what that's saying is that's the ages of the plant. It has to be greater than 0.638. That doesn't sound right. So that's saying the ages of the plant has to be greater than 0.638, so it's less than 1. It's a little bit better than a half a year old. It has to be greater than a half a year old. Number 4, it starts talking about compound inequalities, an and inequality. It says solve. Negative 9 is less than 2x, minus 3 is less than 7. Then graph the solution. Okay, now you don't have a left side and a right side of this problem anymore. Now you have a left side, a middle, and a right side. Anything you do to the middle, you have to do to the left side and the right side. So if you look at, if you just cover up one part of it to where it doesn't bother you, and let me, that's not going to work. Just cover up, say, this side right here. Act like it doesn't exist for a minute. So you have 2x minus 3. You know how to undo minus 3. You add 3 to both sides. You would add it there. You'd have to add it here. Negative 9 plus 3 to give you negative 6. But this is where it becomes different. Because since there is that right-hand side, whatever you did to that left side and that middle, you have to add 3 to this side as well. So when you do that, you get negative 6 is less than, this part cancels out and leaves you with 2x in the middle. And then 7 plus 3 is 10. Then undo the multiplication, 2 times x. Divide the middle by 2. If you divide the middle by 2, divide the left by 2. Negative 6 divided by 2 is negative 3. And 10 divided by 2 is going to be 5. So divide each side by 2. So it says because x is between negative 3 and 5, and you can see it's between negative 3 and 5, the solutions are all real numbers greater than negative 3 and, that's where your and part of your inequality comes in, less than 5. Greater than 3 and less than 5. Now, where that comes in, when you have to read this inequality, negative 3 is less than x is less than 5. You have to read it from the variable. So this part of the inequality is easy for everybody to graph. X is less than 5. So when you're looking at this, you would say less than 5 and you'd say everything that way. But when you read it the other way, you have to read it again from the variable. This way says x, read it this direction. X is greater than negative 3. Greater than negative 3 is showing everything that way, and that's how you wind up with all the numbers between negative 3 and 5. Solve this one. Take about 30 seconds. Shouldn't take you that long. Okay, let's take a look at this one. It says negative 9 is less than t plus 4. 4 is less than 10. Undo the plus 4 by subtracting it. You subtract it in the middle. You have to subtract it on the left and get negative 13. And subtract it on the right and get 6. This part cancels out. You didn't do anything to reverse any of the symbols. So you're left with negative 13 is less than t, which is less than 6. Solving an OR inequality. You do these separate. OR inequalities are usually easier for people because you can do both inequalities separate. 4x minus 2 is less than or equal to 2, or 2x minus 3 is greater than or equal to 3. Add 2 to each side. Looking at the first one first. It says minus 2, so add 2 to each side. It cancels out, leaves you with 4x is less than or equal to 2 plus 2 is 4. Divide by 4. X is less than or equal to 1. So that's the first one. This is the first inequality. Or do the second one. You don't get to choose which one to do. You got to do both of them. 2x minus 3 is greater than or equal to 3. Undo minus 3 by adding to both sides. 3 plus 3 is 6. 2x is greater than or equal to 6. Undo multiply by 2 by dividing both sides by 2. X is greater than or equal to 3. So you have two of them. X is less than or equal to 1, or x is greater than or equal to 3. I had a student in my Algebra 1 class only do one of them because it said or. They said it's or, you could do one or the other. No, it's both of them at the same time. Less than or equal to 1, or greater than or equal to 3. And you graph each of them separate, but you graph both of them on the same number line. And both of them say or equal to, and that's why it's colored in. Less than negative 1, greater than, less than 1, greater than 3. Do this one real quick. I'm going to go through this one where we don't run out of time, everybody. Get rid of plus 9 by subtracting it. 3 minus 9 is negative 6. 6x is less than negative 6. Divide by 6. Negative divided by positive, x is less than negative 1. Notice we did not reverse the symbol for that one because we divided by a positive number. Do the same here. Add 8. 13 plus 8 is 21. 3x is greater than 21. Divide by 3 on both sides. X is greater than 7. So x is less than negative 1, or you write them as one inequality, x is greater than 7. When you graph it on the number line, 0's there, 7's there, greater than 7, negative 1 is here, less than negative 1.